All right. Success Academy, Bronx Middle School Math. We are continuing. So, I made this a separate video in case if you are well versed in the information in the lecture video and you just want practice. You just want to get direct experience of the knowledge you already have. So, let's begin. We're going to be playing a little game this video is made up of mini games, but the game we are starting off with is Guess My Rule. So what we do here is I provide a few shapes and we look at their attributes, we look at the rules that they follow, see what they have in common, and you try to guess which rule I'm thinking of. So here, let's go to a slide giving an imaginary example and an imaginary, like this is the example. So one scholar will choose a rule and keep it a secret. They're not going to tell their friend. They will then draw a shape. After each shape they draw, the other scholars in the group will attempt to answer which rule they picked. So the first scholar, this shape fits my rule. What is my rule? So he draws a square. This scholar draws a square. And he's saying that this square fits his rule, and we have to guess what his rule is. Well, this square follows so many rules. I can't, man, I don't know. You're going to have to draw another shape because this square fits a lot of rules. Give me another hint. Draw another shape. So the scholar will draw another shape, and he draws, oh, it looks like he drew a scalene right triangle. Okay, and he says that here's another shape that fits my rule. Okay, so now we as the audience will try to guess what does this square and this scalene right triangle have in common? And then you will guess, well, is the rule that the shape must have at least one right angle? Yes. That is the rule. That's what these shapes have in common. Right angle, right angle. And so it's our job to look at the common attributes and guess the rule. Okay. So I'm an architect. And my co-teacher, Miss Garcia, you could see here by her little GIF emojis, she comes to me and she says, Miss Tharp, you're an architect. I'm going to give you a set of rules to follow to build my new apartment building that I'm moving into. Yes, ma'am, Miss Garcia. What are your rules? So I figure out the rules to build this building right here. This building must follow the rules of squares and rectangles. Okay, so let's list the rules and attributes that rectangles follow because I see this beautiful pool and that is my inspiration. I'm an architect that lives off inspiration of the world that surrounds me, the world that I am enveloped in. Okay, so let's list the rules that rectangles follow. 4 sides. Okay, that makes it a quadrilateral. Okay, what are some other attributes? Take 10 seconds, pause the video, and write down the attributes that you know for a rectangle. Ready? Go. Okay, now that you've unpaused the video, let's check our answers to see what we have. Did you get 2 pairs of parallel sides, 2 pairs of congruent sides, and 4 right angles? So let's go to this picture. See, these sides, I'm going to change my color because you can't see. Okay, so these sides are congruent. These sides are congruent. They're also parallel, and these are parallel. The pool also has, okay, y'all, this is too cute. Look at this. Do you see how this like little step thing makes a perfect hint that it's a right angle? Look, even the designer of this pool was like, rectangles are right angles. So I'm going to put the little steps in the corner. He was letting us know that rectangles have right angles. So those are the attributes of a right angle. So we could tell that rectangles are quadrilaterals. They have 4 sides. They're parallelograms because they have 2 pairs of parallel sides and 2 pairs of congruent sides. And they have 4 right angles. Well, let's pause the video and write out all the characteristics that a square has. Okay, now that you've written down your answers, I'm going to take a second to explain. I did some reorganization and I put the attributes of the rectangle over here. Let me get on my drawing. There we go. Over here. And then I put the square right here. And then we together are going to put what they have in common right here. I apologize. I realize I can use a typing thing instead of my terrible handwriting, which is much more efficient. So let's move on with this system. All right. So as we said, the characteristics of a rectangle are quadrilateral, four sides. I put dies. No, rectangles are not dying on my watch. Let's fix that. I'm sorry, y'all. Sides. There we go. Okay, so a rectangle is a quadrilateral, four sides, parallelogram, two pairs of parallel sides or dies, and two pairs of congruent lengths. And they have four right angles. Well, let's go over here to the square. What are the attributes of the square? What did you write down? Quadrilateral, four sides, parallelogram, two pairs of parallel sides, and two pairs of congruent lengths. Four right angles. Okay, everything seems to be checking out. Squares and rectangles seem to be the same. But wait, all four sides are congruent in length. Ah, there we go. There we go. Because in a rectangle, the lengths are two pairs are congruent in length only. So here in a square, all four sides are equal in length. So that is what's different. So they share all the attributes except no, let's just put what they share. Let's stick on the positive. They are all quadrilaterals. They are all parallelograms. And squares and rectangles all have four right angles. So I'm an architect, and those are the rules that I need to follow. The shapes in my building need to be four sides. They need to have two pairs of parallel lines and two pairs of congruent lengths. And they need to be four right angles. So if you go over to my building, you will see that I follow that. All of my shapes follow that. You will see nothing but rectangles, quadrilaterals, parallelograms. Whoop, I don't want to make a text. I'm sorry. I did not mean to commit to that. All right, let's go into the next one. See, squares, rectangle, squares and rectangle. So let's look at the rules here. Let's try to figure out what are the rules and these sets, back on the drawing, these sets of lines versus these sets of lines. So the pictures on the left, they seem to be working. Lines that don't touch. But these lines over here, they seem to be touching. Do you remember which lines what are the names for these lines? So when lines are side by side, never touch, versus when lines are like this, they intersect and form a 90-degree angle. Take 5 seconds to pause the video and write down your answers. All right, and the rule is that the lines must be parallel. Because these lines over here, they are perpendicular. They form that 90-degree angle. Okay, let's go on to another one. So this rectangle fits my rule, but the scalene triangle does not fit the rule. So what are the characteristics that these shapes share? Are there any that these shapes share? Well, they're both polygons, I know that. But what does a rectangle have that this scalene triangle doesn't that makes it fit the rule? I'm going to need another shape, so let's go on. Okay, so here I have a rectangle and trapezoid fit the rule, but a scalene triangle and a hexagon don't. So what do these shapes over here have, the rectangle and trapezoid, that the scalene and hexagon triangle don't? Well, just off the top of my head, I can see that this has 1, 2, 3, 4, 1, 2, 3, 4 sides. And a scalene triangle is 1, 2, 3, and hexagon 1, 2, 3, 4, 5, 6. So the rule must be that it must be a quadrilateral because these have four sides, which make it a quadrilateral. But the triangle and hexagon, yes, they share the fact that all these shapes are polygons. They're all part of the polygon family, but only these are part of the quadrilateral family. Let's see if my answer is correct. Hey, and it is. The rule was that the shapes must be a quadrilateral. Okay, let's go into our next example of this. So they've given us a parallelogram that fits the rule, but a trapezoid does not. Well, it can't be the rule that we just came up with before that it must be a quadrilateral because they're both quadrilaterals. So what does a parallelogram have that fits the rule that a trapezoid does not? I'm not too good at this game, so I'm going to need another example to get the answer. Okay, so a parallelogram and a rectangle. These two share an attribute that fits the rule that a trapezoid and a kite do not. Okay, so let's try and figure this out. Let's list the attributes that a parallelogram and a rectangle share first. So pause the video and write down your answers. What are the attributes that a parallelogram and a rectangle share? Okay, here's what I got for the attributes that a parallelogram and a rectangle share. They're both polygon because they both have at least three straight sides. Okay. And they're both quadrilateral. They both have four sides. Let's type that in there. Four sides. At least three sides. And they're both parallelograms because they both have two parallel sides and two congruent sides. Well, polygon can't be the answer because a trapezoid and kite are also polygons. And they don't fit the rule. So I know that that can't be the rule because these are also polygons. And I know quadrilateral can't be the rule because the trapezoid and kite, are also quadrilaterals. They also have four sides. So that can't be the rule. Parallelograms. Okay. Parallelogram and a rectangle are both in the parallelogram family, but a trapezoid is not because it does not have two parallel sides and two congruent sides. And a kite definitely does not have two parallel sides and two congruent sides. So I'm going to put that in. That is my answer. That the rule is it must be parallel. It must be parallelogram. There it is. So the rule was two pairs of parallel sides, a parallelogram. Good job, y'all. Okay. So now we're going to do kind of the same game, but we're switching it up. We're going to give you the rule and you're going to say what shape fits the rule. So we're doing the opposite of the game that we just did. Okay. So what shape fits the rule of I just marked through that rule. Rule 2 and rule 3, but not 1. Okay, so it must be 2 and 3, but not 1. So it must be a quadrilateral with opposite equal sides. Okay, so the opposite sides must be congruent in length. Okay, noted. Rule 3, all congruent sides. So if we take it rule by rule, a quadrilateral with opposite equal sides, that could be a square, that could be a rhombus, that could be a rectangle, and that could be a parallelogram because it's a quadrilateral with opposite equal sides. Okay, now we're going to apply rule 3, all congruent sides. Okay, so that means that all the lengths need to be the same. Well, that takes out rectangle and that takes out parallelogram. So now we're left with a square and a rhombus because they're quadrilateral and all sides are the same length. But it cannot follow rule 1. Meaning, okay, so must have an acute angle. So if we're not following rule 1, that means that it can't have an acute angle. Well, a rhombus, does it have an acute angle as we said? This one would be obtuse. Oh, that's an acute angle. It is less than 90 degrees, which makes it an acute angle, leaving us with a square where it has four right angles, no acute angles. So all 90 degrees. Let's see if we're right. All right, a square. We got it right. Go Bronx. SABXMS. All right. I'm going to pause the video and let you figure this one out for yourself, and then we can check our work together. Pause the video for as long as it takes you, and then we'll come back. Okay. Now that you've unpaused the video, let's check our work. Or you can help me figure this out. So it has to fit Rule 1 and Rule 2, but it cannot follow Rule 3. So Rule 1 must have an acute angle. Okay, a lot of shapes have acute angles, like equilateral triangle, or parallelograms have rhombus, kites. Okay, now let's go on to Rule 2. A quadrilateral with opposite equal sides. Oh, okay, well, that takes out triangle and rhombus. Because with the rhombus, adjacent sides are equal in length, but not opposite. So what are we left with? We are left with a parallelogram. That fits Rule 1, have an acute angle and quadrilateral with opposite equal sides. Yeah, and a rhombus. Those fit both Rule 1 and 2. Now we need to make sure that it does not fit Rule 3. It needs to go against Rule 3. All congruent sides. Oh, man. Okay, well, that takes out the rhombus because with the rhombus, all sides are equal. So we are left with the parallelogram. Let's see if we're correct. Hey, hey, way to go, Idaho. Parallelogram. That's what I'm talking about. Okay, we're going to have one more example and we're going to do the same thing. Pause the video to make sure that we can do this on our own, and then you can come back and help me out. Ready? Go. All right, let's check our work. So it must fit Rule 1, but not Rule 2 and 3. So check on 1, it must have an acute angle, but it cannot follow Rule 2 and 3. So what shapes have an acute angle? Well, we have triangles, it could be equilateral, it could be scalene where all sides are different. What are other shapes that have an acute angle? As we said, kites, parallelograms, rhombuses. Okay, so now that we have shapes with acute angles, which again, less than 90 degrees. Let's move on to rules 2 and 3 to make sure that they do not follow those rules. Okay, so rule 2, it cannot be a quadrilateral with opposite equal sides. Ah, fiddlesticks. Okay, well, that means that it can't be a rhombus, it can't be a parallelogram, but it can still be a kite because a kite doesn't have opposite equal sides, and it can still be all these triangles because a triangle is not a quadrilateral. Now let's see if it fits rule 3, all congruent sides. So that took out the rhombus because a rhombus has all equal sides. So what I'm left with are these triangles and kites. Let's see if that's the correct rule. There we go. We have a scalene triangle right here. An equilateral triangle would have worked also. And this kite, notice how the lengths that are congruent or equal to each other are adjacent. These are next to each other. Discourse. Okay, so I'm going to ask you some like mind thought provoking questions that can help wrap up all the material that we have learned in practice to make sure that you fully understand and are capable of applying the knowledge. So let's go on. And after each question, pause the video, write down your response to make sure that you can do this independently. What are attributes and properties in geometry? What are the attributes to a quadrilateral shape? Does the orientation of a shape affect its attributes or classifications? Is it possible for a shape to have multiple classifications or labels? Make sure that you support your answer for all of these questions. And I want you to be able to talk out and explain your answers. Ready? Go. Okay, here are the answers to the first two. What are attributes and properties in geometry? Remember, these are the characteristics that belong to an object or a shape to help us classify the shape. The attributes and properties are the details we notice in shapes to help us put them in the correct family. So we go, okay, they have at least three sides, so that means they're in the polygon family. And they have two pairs of parallel sides and two pairs of congruent links. So they're in the parallelogram family. So we use it to classify and characterize them. What are attributes to a quadrilateral shape? Well, a quadrilateral shape is in the polygon family because it has at least three sides. It is two-dimensional, and a quadrilateral has four straight sides. Let's move on to the next. Does the orientation of a shape affect the attributes or classifications? So, this question can be confusing by the word orientation. What we mean by that is like if you rotate a shape to the side, does that affect the attributes or classifications? No. Despite the orientation or the rotation of the shape, the parallel lines, congruent sides, the number of sides do not change when you rotate the shape. So let's say I have a triangle that's facing this way and I'm going to rotate it to where it's now on its side. That is not a big difference. I'm sorry. I'm terrible at this. So now we rotated this triangle, but all the attributes are the same. This triangle still has three sides, and whether or not it is a scalar and equilateral is still the same. We just rotated it. Let's do it with a rectangle. So if I have a rectangle like this, and I rotate it to where it's on its side now, it's still the same. It's kind of like when you have a picture, you take a selfie and for some reason it's like rotated the wrong direction and you have to go to settings and do rotate 90 degrees. The attributes of the picture are still the same. You are going to look just as pretty in the selfie before and after you rotated it. Your attributes do not change when you rotate the image. Just the orientation of the shape is changed. Let's move on to the next one. Is it possible for a shape to have multiple classifications or labels? Yes. As we said before, shapes can be a part of many families. A shape can follow the rules for multiple classifications at the same time. For an example, a square follows the rules for a polygon, quadrilateral, trapezoid, and parallelogram. So a square is going to go to Christmas for polygons because it's part of the polygon family. It's going to Thanksgiving with quadrilaterals because it is part of the quadrilateral family. It has four sides. And you know that it's going to Christmas with trapezoids because it does have at least one pair of parallel sides. And it celebrates its birthday with parallelogram because they both have two pairs of parallel sides and two pairs of congruent links. So the square is a part of many families. However, this does not mean that the categories are synonymous. So, not all parallelograms are rectangles. And not all trapezoids are parallelograms. But all parallelograms are trapezoids. All right, I hope all of these examples and practice problems were helpful. And make sure, let's get lots of practice so that we can do our best on the test. Continue to practice. Good job, y'all. Have a good day.